Hello, my friend. Right now, light is touching your eyes that left its source long before you were born. Some of it crossed an emptiness so wide it has no comfortable name. Some of it set out when the world was far younger, and it has been traveling ever since, arriving at the close of your day, soft against your eyes, just in time to be among the last things you see before sleep. We are wrapped in light through every moment of our lives, and we almost never stop to wonder what it truly is. It is the oldest messenger in the universe and the strangest. You can feel it on your skin as warmth, and yet you can never quite hold it. It carries the faces of the people you love, and it carries the image of stars that no longer exist. It is the fastest thing there is, and somehow, moving at its own impossible speed, it feels no passage of time at all. Tonight, there is nothing here for you to understand. There is only rest. Let your shoulders grow heavy. Let your breathing slow, and let your thoughts loosen and drift, like something gently set down at the end of a long day. For the next little while, we'll wander through the quiet mysteries of light, the questions that have softly haunted the people who study it most. Nothing to solve, nowhere to be. Just let the wonder carry you, one gentle thought at a time, down towards sleep. The stars you see tonight may not be there anymore. It sounds like a strange thing to say about the calm, familiar points of light scattered across the dark. They look so permanent, so fixed, the same patterns your grandparents looked up at, the same ones that guided ships across black oceans long ago. And yet not one of those stars is showing you itself as it is right now. Every single one is showing you its past. Light is fast almost beyond imagining, but it is not infinitely fast. It travels at a fixed speed, and space is so enormous that even at that speed, light takes time, sometimes a great deal of time, to cross it. The light from our own sun, the nearest star to us, takes a little over 8 minutes to reach the Earth. So when you feel the warmth of morning sunlight on your face, you are feeling sunlight that left the sun 8 minutes ago. If the sun were to simply vanish, you would go on seeing it, shining as if nothing had happened, for 8 more minutes before the sky went dark. Now lift your gaze past the sun, out to the stars. The next nearest star to us is so far away that its light takes more than 4 years to arrive. So the light you catch from it tonight set out 4 years ago, when your life was a little different, when the world was a little different, and it has been racing toward you across the dark every second since. You are seeing that star not as it is, but as it was, 4 years deep into the past. And these are the close ones, the nearby neighbors. Many of the stars sprinkled across the night sky are hundreds or thousands of light years away. Their light has been traveling toward you since before there were cities lit by electricity, since before the great cathedrals were built, since before some of the languages we speak today had even taken shape. When that light first left its star, the world it would eventually fall upon did not yet exist in the form you know, and all that time it simply traveled, patient and silent, until tonight it slipped quietly into your eyes. This is why the night sky is, in a very real sense, a window into the past. You are not looking out across space alone. You are looking back through time. The deeper you look, the further back you go. Every glance upward is a glance into history, layered and overlapping, light from 1,000 different moments all reaching you at once. And here's the part that gives so many people a soft chill of wonder. Because that light is so old, some of the stars that sent it may no longer exist. A massive, distant star could have burned through the last of its fuel and collapsed, or blown itself apart in a brilliant death long, long ago. And yet its final light is still in flight, still crossing the gulf, still arriving. We would go on seeing it shining peacefully in our sky, unaware, for as long as that ancient light kept coming. We would be watching a ghost, a light still traveling from something that is already gone. There is a strange comfort in that. Nothing we love is ever truly lost while its light is still arriving. The astronomers who study the most distant reaches take this even further. When they point their great telescopes at faint smudges of light unimaginably far away, they are looking back across millions, even billions of years. They are seeing galaxies not as they are now, but as they were when the universe itself was young. To look far enough out into space is, in a sense, to look almost all the way back to the beginning. The farther the distance, the older the story the light has to tell. So the next time you stand beneath a clear night sky, let yourself feel the truth of what you are seeing. That soft, scattered glow above you is not a single moment. It is a vast, silent gathering of the past, ancient light from countless different ages, each beam carrying news of how things once were, all of it arriving at the very same time, just for you, just now. Some of those points of light are messages from worlds that still shine. Some may be the last letters from stars that have already gone dark, and there is no way, simply by looking, to tell which is which. They all look the same to us, calm and steady and unbothered, patiently keeping the night company. Tonight, you don't need to know which stars still burn and which have faded. You only need to let their old light rest on you, soft as a blanket, pulled up in the dark, light that set out across the universe long before this moment, traveling all that way through the silence only to find you here, drifting towards sleep exactly when it arrived. Chase after a beam of light as fast as you possibly can, and it will always slip away from you at exactly the same speed. This is one of the quietest, strangest facts in all of science, and it sounds at first like it must be a mistake. Imagine you are standing still and a beam of light races past you. It moves at a particular speed, an enormous speed, around 300,000 kilometers every second, fast enough to circle the entire Earth more than 7 times in the time it takes to say a single word. Now imagine you begin to chase it. You build an impossible ship and you push it faster and faster until you are moving at a tremendous fraction of that speed yourself. Surely, you think, the light should now be pulling away from you more slowly. You've closed the gap. You're nearly keeping pace, but you are not. You measure the beam again, and it is still racing away from you at exactly the same speed as before, as though you had never sped up at all. It does not matter how fast you go. It does not matter in which direction. Every observer, everywhere in the universe, no matter how they are moving, measures the speed of light to be precisely the same. The person standing still and the person flying along at a breathtaking pace both clock that same beam at the same unchanging speed. Light simply refuses to be caught, refuses to be slowed, refuses to be hurried by anything you do. This seems impossible because it breaks the simple, sensible arithmetic we use every day. If you're on a train moving quickly and you walk forward along the aisle, someone watching from outside sees you moving at the speed of the train plus your own walking speed. Speeds add together. That is how the world feels. and yet light does not play by that rule. Add all the speed you like, and light still flees at the same rate. The young man named Albert Einstein took this strange fact seriously, more seriously than almost anyone before him. He asked a simple question. If the speed of light never changes no matter how you move, then something else must. Something has to bend to keep that speed constant. And what he realized, slowly and carefully, is that the things we always assumed were fixed and solid, time itself and the lengths of things, are the very things that quietly give way. Here's what that means as gently as it can be put. When you move very fast, time for you actually begins to slow down compared to someone standing still. Not as a trick of the clock or a flaw in the machinery, but truly. Moving clocks tick more slowly. A fast-moving traveler ages more slowly than the people they left behind. And lengths shorten too. A fast-moving object is measured as slightly squeezed in the direction it travels. The universe rearranges space and time, stretching one and shrinking the other, all to protect that one unbreakable rule. Light's speed stays the same, and everything else bends around it. This is not a guess, and it is not just a clever idea on paper. We have measured it. Tiny particles that live for only a flash of time survive far longer when they move near the speed of light, because their internal clocks really do run slow. The satellites that hum quietly overhead, guiding us through our days, have to account for these effects, or the directions they give us would drift wrong within hours. Time genuinely flows at different rates for things moving at different speeds. We live inside this truth every day, quietly, without ever feeling it. And so light becomes something more than fast. It becomes a kind of cosmic limit, a boundary woven into the very fabric of reality. Nothing that carries mass can ever quite reach it. As you push an object faster and faster toward that speed, it grows harder and harder to push, as though the universe itself leans against the effort, until reaching the speed of light would take an impossible, endless amount of energy. Light gets to travel at that speed because it weighs nothing at all. The rest of us, made of heavy and patient matter, can only ever draw close. There is something almost tender in this if you let yourself feel it. The universe does not let you catch the light, but it does not simply forbid it either. Instead, it quietly reshapes time and space themselves, folding and stretching them, doing whatever it takes so that the rule is never broken. The price of that constant, faithful speed is paid in the bending of reality. So light slips ahead of everything, always, by the same unchanging margin. The fastest ship you could ever dream of, and a single beam of starlight would still part ways at that same fixed speed, the traveler falling behind no matter how hard they tried, the light gliding on, calm and untouchable, into the dark ahead. Tonight there is nothing for you to chase. Let the thought of all that speed settle into stillness. Somewhere far above you, light is moving at the only pace it has ever known, steady and serene, carrying the whole structure of space and time gently along with it. Look up on a clear night, and the first thing you notice is not the stars. It is the darkness between them. We take that darkness for granted. Of course, the night is dark, we think. The sun has gone down, and the light has gone with it. But there is a much deeper puzzle hidden in that quiet black sky. A puzzle so simple that a child could ask it, and so strange that it took some of the finest minds centuries to answer. The question is this: why is the night sky dark at all? It sounds almost foolish until you really sit with it. Imagine for a moment that the universe is endless in every direction, stretching out forever, and that it has always existed, unchanging, filled evenly with stars. If that were true, then no matter which way you looked, your line of sight would eventually land on the surface of some star. Near or far, it would not matter. Look in any direction, follow that line far enough, and somewhere along it, a star would be shining. Every single point in the sky would be filled with starlight. And if every point in the sky held a star, then the whole sky, in every direction, would blaze. The night would not be dark at all. It would be a solid wall of light, as bright and as searing as the surface of the sun, with no gaps and no shadows anywhere. There would be no night. There would be no soft darkness to sleep beneath. The heavens would burn from edge to edge all the time. But that is not what we see. We see a sky that is overwhelmingly dark, scattered with separate points of light, with vast stretches of black emptiness between them. The darkness wins. And the fact that it wins is telling us something profound about the universe we live in. This puzzle has a name. It is often called Olber's paradox, after an astronomer who pondered it long ago, though others wondered about it before him. For a long time, no one could quite explain it. If the universe is full of stars, where did all the light go? Why is the sky not on fire? The answer, when it finally came, was beautiful, and it reshaped how we understand everything. The first part of the answer is this: the universe is not infinitely old. It had a beginning. As far as we can tell, everything we can see came into being a finite time ago, somewhere around 14 billion years in the past. And because light travels at a fixed speed, it can only have traveled a certain distance in that time. Light from stars beyond that distance simply has not had enough time to reach us yet. It is still on its way. So when you look out into the dark, you are not seeing an endless wall of stars. You are seeing only as far as light has been able to travel since the universe began. Beyond that edge, there may be more, but its light has not arrived and may not for a very long time. The darkness, in part, is simply the places whose light is still in transit. And there is a second part, just as strange. The universe is not standing still. It is expanding. Space itself has been stretching, carrying distant galaxies ever farther from us. And as that space stretches, it stretches the light traveling through it. Light from the most distant reaches gets pulled and lengthened until it slides out of the colors our eyes can see, dimming and reddening into forms of light that are invisible to us. So even some of the light that does reach us arrives drained and faded, shifted into a glow our eyes were never built to catch. Put those two truths together, and the dark night sky begins to make a quiet, perfect sense. The darkness is not empty. The darkness is a message. It is telling you that the universe had a birth, that it has not always been here, and that it is growing, carrying its farthest lights gently out of reach. The black spaces between the stars are not nothing. They are the signature of a cosmos with a beginning and a history, written across the whole sky in shadow. There is something humbling in that thought. For most of human history, people gazed up at the dark and assumed it was simply the absence of light, the plain backdrop against which the stars were hung. And all along, that darkness was carrying one of the deepest truths there is: that time itself has an edge, that the universe is young enough and wide enough and growing fast enough that the night can stay dark and gentle above us. So tonight, when you picture that quiet black sky, you can let the darkness mean something soft and astonishing. It is not emptiness. It is the universe whispering its own age, its own vastness, its own slow unfolding. The dark between the stars is the reason you can rest beneath a calm and shadowed sky at all. A darkness that exists because the cosmos had a beginning and is still, even now, quietly growing outward into the night. Light cannot seem to decide what it is, and after 100 years of looking, neither can we. For most of history, people argued over a simple question. Is light a wave, like a ripple spreading across a pond, or is it a stream of tiny particles, like a spray of impossibly small grains? Both ideas seem to explain some of what light does, and great thinkers lined up on both sides. It felt like the kind of question that ought to have a single, tidy answer. Light must be one thing or the other. It turned out that light is stranger than either side imagined. To see why, picture a simple experiment, one you could almost set up on a kitchen table. You take a barrier with two narrow slits cut into it side by side, and you shine light at it. On the far side, you place a screen to catch whatever comes through. If light were simply a stream of little particles, you would expect two bright lines on the screen, one behind each slit where the grains piled up after passing through. Simple enough. But that is not what happens. Instead, the screen lights up with a whole series of bright and dark stripes, many of them spread out in a pattern. And this is exactly what waves do. When a wave passes through two openings, it spreads out from each one, and the two spreading waves overlap. Where two crests meet, they add together and grow stronger, making a bright band. Where a crest meets a trough, they cancel each other out, leaving darkness. The striped pattern on the screen is the fingerprint of waves rippling, overlapping, and interfering. So light, it seemed, was settled at last. Light was a wave. Except the story does not end there, and here's where it begins to feel like a dream. We can now make light so faint that it travels as the tiniest possible pieces, single particles of light called photons, sent out one at a time, like releasing one drop of water and waiting, then releasing another. Each single photon strikes the screen and leaves a single tiny dot, exactly as a particle should. One dot, then another, then another. So light is made of particles after all. But watch what happens as the dots build up. You send through one photon and it lands somewhere. You send another and it lands somewhere else. One by one, dot by dot, you let thousands of them go, each one alone, each one arriving by itself with no companions to ripple against. And slowly, out of all those separate, solitary dots, the same striped pattern appears. The bright bands and dark gaps build themselves up, point by point, exactly as if waves had been overlapping all along. Sit with that for a moment, because it is genuinely astonishing. Each photon was sent alone. There were no other photons present for it to interfere with. And yet the pattern that forms is the pattern of something passing through both slits at once and overlapping with itself, as though each single particle of light somehow traveled through both openings at the same time, exploring every path, and only settled into a single point when it finally arrived. Each one alone, and yet each one behaving like a wave that fills all the possibilities. And it grows stranger still. Suppose you become curious and decide to peek, to place a tiny detector at the slits, just to catch which one each photon actually goes through. The moment you do, the moment you gather that information, the striped pattern vanishes. The light stops behaving like overlapping waves and goes back to behaving like simple particles, two plain lines on the screen. Look to see which path it takes, and it takes only one. Look away, and it somehow takes them all. This is one of the deepest and most honestly unsolved puzzles in all of physics. It is not that we lack the equations. The mathematics describes exactly what we will see with breathtaking precision. What we lack is a comfortable picture of what is really happening underneath. Is the photon a wave that becomes a particle when measured? Is it something with no everyday name at all? Something our words for waves and particles simply fail to capture? The experiment works every time. The meaning of it is still quietly debated by thoughtful people to this very day, and no one can honestly claim to have the final word. What it seems to whisper is that reality, at its smallest scale, is not the solid, settled thing we imagine. Down at the level of single particles of light, the world appears soft and undecided, holding many possibilities at once, choosing only one when it is looked at. The firm, definite world we know may rest on a foundation that is far more dreamlike than we ever expected. You do not need to resolve any of it tonight. You can simply let it be the gentle mystery that it is. Light, the most familiar thing in the world, quietly refusing to be only one thing. A wave and a particle and something beyond both, slipping through every path at once in the dark and settling softly only when the universe takes a look. From the point of view of a beam of light, there is no journey at all. This is one of the most haunting ideas to come out of our understanding of the universe, and it asks you to imagine something almost impossible to picture. We are used to thinking of light as the great traveler, crossing unimaginable distances, taking thousands or millions of years to journey between the stars. And from where we sit, watching, that is exactly true. Light takes time to get places, sometimes a staggering amount of time. But there is another way to look at it, a stranger way, and it turns everything quiet and still. To understand it, we have to begin with something gentle and well-tested. The faster a thing moves through space, the more slowly time passes for it. This is not a fragile theory. It is measured, confirmed, woven into the technology around you. A clock racing along at tremendous speed truly ticks more slowly than a clock sitting still. A traveler moving very fast ages more slowly than the friends they left behind. The faster you go, the more time itself seems to relax and stretch, slowing down for you while it runs on as usual for everyone else. Now follow that idea all the way to its edge. As something moves faster and faster, approaching the speed of light, time for it slows more and more dramatically. And light itself moves at the very speed that everything else can only approach. So what would happen to time at that ultimate speed? The mathematics gives a startling answer. For something moving at the speed of light, time would not pass at all. It would stand perfectly still. The moment the light is created and the moment it is absorbed, no matter how many billions of years and how many trillions of miles lie between them for us, would happen in the very same instant. There would be no waiting and no long crossing of the dark. The light would be born and would arrive in a single timeless now, and the distances collapse along with the time. Just as fast motion slows time, it also shortens space in the direction of travel. Push that to the speed of light, and the entire distance shrinks away to nothing. A journey that looks to us like 1,000 years across a vast gulf of space would, from light's own vantage, be no distance and no duration at all. The light does not experience the long dark crossing we imagine. For the light, there is no crossing. Departure and arrival are the same event. Here it is worth being careful and honest, because this idea is so often stretched too far. Strictly speaking, the rules that govern motion do not allow for a true point of view that travels at exactly the speed of light. There is no valid frame in which you could sit and ride along beside a beam, looking out. So this is not quite a literal experience that light has in the way you have experiences. It is instead that the place the equations point toward when you follow them all the way to the limit. A vivid shadow cast by the mathematics, telling us that as you draw near to light's speed, time and distance melt toward nothing. The light, in this strange and careful sense, is the closest thing there is to something standing outside of time. Even held at arm's length, the thought is staggering. The starlight that lands softly on your face tonight may have left its source thousands of years ago. By our reckoning, to us, it has been traveling all that time, patient and alone, through the cold and the dark. But from the light's own side of things, no time has passed since it set out. It was emitted from a distant star, and it touches your eyes here, now, in what is, for the light, the very same moment. The whole long voyage we picture, all those centuries of silent travel, would for the light be no voyage at all. It simply is at its star and at your eye at once, the beginning and the end pressed together into a single point. There is something deeply peaceful in that, if you let it settle over you. We tend to think of light as endlessly hurrying, rushing across the cosmos at the greatest speed there is. And yet, in this other sense, light may be the most restful thing in all of creation. For light, there is no long road and no weary wait. There is no aging, no before and after, no time slipping away. Only the gentle, instant arrival. So when ancient starlight finally reaches you tonight, you might think of it not as a tired traveler at the end of a long road, but as something that never felt the distance at all. From its own quiet vantage, it left its star and found you here in the same breathless instant, ageless, unhurried, untouched by all the time that we believe has passed. Let that stillness be yours for a while. Somewhere out there, light is crossing the universe, and from its own side of things, it is going nowhere and no when, resting in a single timeless moment, arriving exactly when it always already had. There's no red in a rose, and there's no blue in the sky. It sounds like a riddle or a small piece of nonsense, but it is one of the truest and most surprising things you can learn about the world you see. The colors that fill your life, the green of summer leaves, the gold of late afternoon, the deep blue of the evening sky, are not actually out there in the light itself. They are something your own mind makes. The universe, in a real sense, has no color at all. Color is painted on from the inside by you. To understand how strange this is, we have to be careful about what light really carries. Light travels as waves, and those waves come in different lengths. Some are a little longer, some a little shorter, and that length is a simple physical fact about the light. There is nothing colorful about it. A wavelength is just a measurement, like the height of a person or the distance between two stones. The light arriving from a rose has waves of a certain length, and the light from the sky has waves of another, lengths and nothing more. No redness travels through the air. No blueness rides along the beam. What happens next happens inside you. At the back of your eyes, there are tiny cells that respond to light, and a few special kinds of them are sensitive to those different wavelengths. When light of a certain length lands on them, they send a signal inward. Your brain gathers up those signals and does something quietly miraculous with them. It invents an experience. It conjures out of pure darkness inside your skull the rich sensation you call red or green or blue. The wavelength comes in as a plain physical fact, and the feeling of color blooms in your mind in response, like a private flower that no one else can ever quite see. This is why color is, in the deepest sense, a kind of beautiful invention. The wavelengths are real. The colors are your mind's way of telling them apart. A language of sensation your brain built so that you could make sense of the light. Outside your head, there are only waves of different lengths, sorting silently through the air. Inside your head, that silent sorting becomes a glowing, living world of color. And there are clues all around that the colors live in the seeing and not in the thing seen. Different creatures build different colored worlds from the very same light. Some animals can sense wavelengths your eyes cannot, seeing patterns on flowers and feathers that are completely invisible to you. Others see fewer colors than you do, living in a simpler, gentler palette. The light reaching all of you is the same. The worlds you each paint from it are wonderfully different. There is no single true set of colors hanging in the air for everyone to share. There are only the wavelengths, and the many minds turning them into many private visions. There is an even stranger hint hiding in plain sight. Think of the color you might call magenta, or a vivid pink, that lovely shade between red and violet. If you look carefully at the way wavelengths spread out, from the long waves we call red all the way to the short ones we call violet, you will find that magenta is not there. It has no wavelength of its own. It is not a color of light at all. It is something your brain produces when it receives red and violet light together and decides, all on its own, to blend them into a single new sensation that exists nowhere in the light itself. A color invented entirely within you, with no thread of it anywhere in the outside world. When you really take this in, it changes the way you see seeing. The glowing, colorful world that feels so solid and so obviously out there is, in a quiet way, happening within you. You are not simply receiving a colorful world. You are creating one, moment by moment, out of plain waves and the gentle work of your own mind. The sunset is not red in itself. The sky is not blue in itself. They are wavelengths, and you are the one who turns them into beauty. There is something tender about that, and something a little lonely, and something wondrous all at once. Every person who has ever looked at the evening sky has made their own version of its color, alone inside themselves, and trusted that it matched yours. We share the light. We can never quite share the color. Each of us walks through a world we are quietly painting as we go, certain it is simply there. So tonight, as the last colors of your day soften and fade, you can hold this gentle thought. The rich hues you have seen today were never floating in the air, waiting to be found. They were yours, made within you, by you, out of nothing but waves of light and the quiet magic of being able to see. A whole colored world, blooming in the dark behind your eyes, ready now to dim and settle as you drift towards sleep. The oldest light in the entire universe is reaching you right now, and it is older than every star in the sky, older than the sun, older than the earth, older than the most ancient stars you could ever hope to see. This light has been traveling for very nearly the whole age of the universe, close to 14 billion years, and it is still arriving in this very moment from every direction at once. It is the faint, far afterglow of the beginning of everything, and it surrounds you always, soft and unseen. To understand where it comes from, we have to imagine the universe when it was very, very young. In its earliest days, everything that exists now was packed unimaginably close together, and it was searingly hot, so hot that ordinary matter as we know it could not yet hold together. The whole cosmos was a glowing, churning fog, a dense haze of particles too restless to settle, and in that state, light could not travel freely. It was constantly bouncing, scattering, trapped within the fog, unable to go anywhere, like sunlight lost inside a thick bank of cloud. The early universe was glowing everywhere, and yet it was sealed in its own brightness, unable to let that glow escape. Then, slowly, the universe did what hot things do. Given time, it expanded and it cooled. And after a stretch of around 400,000 years, a mere blink compared to the ages that would follow, it cooled just enough for something quietly momentous to happen. The swirling particles finally calmed and joined together into the first complete, stable atoms. And in that moment, the fog lifted. All at once, across the whole young cosmos, space became clear. The light that had been trapped, bouncing endlessly, was suddenly set free to travel in long, straight lines out across the newly transparent universe. That release of light is what still reaches us today. It has been streaming through space ever since that ancient moment of clearing, never absorbed, never stopped, simply traveling for almost the entire history of time. We call it the oldest light, and it carries a picture of the universe as it was at the very edge of what we can ever see, a snapshot of the cosmos when it was just emerging from its first glowing infancy. But it has changed on the long way here, and this part is lovely. When that light was first set free, it was bright and hot, the glow of a young and fiery cosmos. Yet across the billions of years of its travel, the universe never stopped expanding, and as space itself stretched, it stretched the light traveling through it. The waves were pulled longer and longer, gentler and cooler, sliding down out of the brilliant glow it once was, until today it arrives not as visible light at all, but as faint microwaves, a whisper of warmth only a few degrees above the coldest temperature there can be. The fierce light of the early universe has been soothed by all that time and distance into the softest possible glow. And here's the detail that brings it close to home. This ancient light is not confined to deep space or to the great telescopes of astronomers. It is here, passing through you and the room around you right now, arriving steadily from every direction. In the days of older televisions, the ones that hissed with gray static between the channels, a tiny part of that flickering snow was this very light, the afterglow of the beginning, picked up faintly by the antenna along with everything else. People sat in their living rooms, gazing at a little of the oldest light in existence, and never knew it. There is a quiet wonder in that, almost too large to hold. The faint warmth that fills all of space is the universe's first light, the closest thing there is to an image of its birth. It has been traveling, untouched, since before there were galaxies or stars or planets, since before there was anything we would recognize, and it did not stop for any of it. It simply kept coming, patient beyond imagining, until at last a small part of it arrived here, in your time, in your place, gently washing over you as you settle down for the night. When you let yourself feel the scale of it, it can fill you with a soft and humbling peace. You are not separate from the beginning of all things. The oldest light there reaches you as surely as it reaches the farthest galaxy. The whole long story of the universe, from its first clear moment to this quiet night, is connected by that faint and faithful glow, still arriving, still surrounding you, even now. So as you close your eyes tonight, you can hold this gentlest of thoughts. All around you, unseen and unfelt, flows the most ancient light in creation, the soft afterglow of the very beginning, traveling for nearly 14 billion years through the dark, only to be here with you, wrapping the whole world in the faint warmth of the cosmos, remembering how it began. Most of the light around you right now is completely invisible. It is a strange thing to sit with. We tend to think of light as the bright, colorful world we can see, the glow of a lamp, the blue of the sky, the soft gold of evening. But the light your eyes can detect is only the thinnest sliver of something far, far larger. All around you, passing through the room, through the walls, through your own body, flows a vast ocean of light that you will never see with your eyes, no matter how hard you look. And it has been there your whole life, silent and unnoticed. To understand this, picture the light we can see spread out into a rainbow, the way sunlight breaks apart in a prism or across the sky after rain. At one end sits red with its long, lazy waves. At the other end sits violet, with waves much shorter and tighter. That band, running from red to violet, is everything your eyes were built to catch. It feels like the whole of light, but it is only a tiny window, because the waves do not stop at red. Just past the red, the waves grow longer, and there the light becomes invisible to you, though it is every bit as real. This is the realm of infrared, and you have felt it many times without ever knowing. When you hold your hands near a warm stove or feel the heat of a fire on your face from across a room, that warmth traveling to you through the air is infrared light. Light too long for your eyes to see, arriving as a gentle warmth on your skin. Every warm thing glows with it, softly, all the time. You are glowing with it now. In complete darkness, a camera built to see infrared would find you shining like a soft lantern, painted in the heat of your own living body. Keep going past the infrared, and the waves grow longer still, into microwaves, the very same kind of waves that warm your food, and longer again into radio waves, some of them longer than buildings, longer than mountains. And here is something quietly astonishing. The air around you is thick with radio waves at every moment, carrying music and voices and messages, passing straight through the walls and straight through you as though you were not there. If you could see radio light, the night would not be dark at all. It would shimmer and hum with countless signals, an invisible weather of light washing endlessly over everything. Now go the other way, past the violet, where the waves grow shorter and shorter. Just beyond what you can see lies ultraviolet, the light that slips past your notice on a bright day and quietly tans or burns your skin. Shorter still, and you reach X-rays, the light that can pass through soft flesh to reveal the bones beneath. Shorter again, and there are gamma rays, born in the hearts of exploding stars in the most violet places in the universe. All of it, the radio and the infrared and the visible and the ultraviolet and the X-rays and the gamma rays, all of it is the very same thing. It is all light. The only difference between them is the length of the waves. They are all members of one single family, stretching out endlessly in both directions, and your eyes can see just one small beloved sliver in the middle. Here's the quiet wonder of it. Your eyes settled on that particular sliver for a beautiful reason. It is the band of light our sun pours out most strongly, and the band that passes most easily through air and water. Life learned to see in exactly the window where there was the most to see. We are tuned perfectly to our own small star and our own clear sky. But that tuning, lovely as it is, means we walk through the world half blind to the riches around us, catching only the colors that mattered most for living and missing the vast invisible glow that fills the rest of the world. Think of what it would be to see it all. The dark room around you would be alive with light. The warm shape of your own body glowing in infrared. The soft heat rising from a sleeping pet. The hum of radio drifting through the walls. The faint ultraviolet shimmer of the world outside. Reality, it turns out, is drenched in light from end to end, far more of it than we ever perceive. The darkness we imagine is mostly just light we were never built to notice. There is something gently humbling in knowing this. The world is so much fuller than it appears to us. Every quiet, ordinary moment is steeped in a brilliance we cannot see, a constant, invisible radiance pouring through the air and through ourselves. We are never truly in the dark. We are simply standing in colors we have no eyes for. So tonight, as you lie still in what seems like darkness, you can let yourself feel the truth of it. The room is not empty, and it is not dark. It is full of soft, unseen light, drifting through the walls and over your skin and through the very space you breathe, an endless, invisible glow holding you quietly as you let your eyes close and drift down into sleep. In the darkest place on earth, living things make their own light. Far below the surface of the ocean, deeper than sunlight can ever reach, lies the largest and darkest habitat on our entire planet. It is a world of perpetual night, cold and still and black, stretching down for miles. No daylight has ever touched it. And yet it is not without light, because down there, in that endless dark, countless creatures carry their own glow, and the deep sea flickers and pulses with a soft, living light made entirely by the things that live in it. This is bioluminescence, the light that life makes for itself. It is not a reflection, and it is not borrowed from the sun. It is light created from the inside through a gentle chemistry happening within the creature's own body. Deep in their tissues, certain animals carry special ingredients that, when they meet and react, release their energy as a glow. It is a little like the chemistry inside a glow stick, the kind you might bend and shake until it shines, except here, the glow is alive, woven into the body of a breathing thing. Scientists have names for those ingredients. The substance that glows is often called luciferin, and a helper that sets the reaction going is called luciferase, names drawn from an old word for the bringing of light. When the two meet in the presence of a little oxygen, the energy of that small reaction slips out as light rather than as heat. It is chemistry, plain and real, and yet the result looks like magic. A creature quietly shining in the dark. And here is one of the loveliest details. The light these creatures make is almost completely cold. When we light a bulb, most of the energy is wasted as heat, and only a little becomes light, which is why a lamp grows warm to the touch. But living light is different. Nearly all of its energy becomes light, with scarcely any heat at all. A glowing fish or jellyfish shines softly in the cold water without ever growing warm. It is among the most efficient light in the world, perfected over countless ages by life itself, long before we ever struck a match. The deep ocean uses this light in ways both beautiful and strange. Some fish dangle a glowing lure in front of their mouths, a tiny living lantern that drifts in the black water to draw curious prey close. Some creatures, when frightened, release a sudden burst of light into the water, a dazzling flash that startles a predator or lights it up for something larger to notice, a kind of living burglar alarm in the dark. Others wear rows of soft lights along their bellies, glowing just enough to erase their own shadow against the faint glow filtering from far above, so they seem to vanish, hidden by their own gentle shine. In that lightless world, the ability to make light became a language, a lure, a shield, and a disguise, all at once. And it is not a rare trick reserved for a few odd creatures. In the deep ocean, the ability to glow is closer to the rule than the exception. Scientists who have studied that vast dark water believe the great majority of the animals living there can produce their own light in some form. Imagine that for a moment. A world larger than every continent combined, almost entirely dark, where most of the living things you would meet are softly luminous. It may be one of the most common ways to be alive on this whole planet, and it happens almost entirely out of our sight. And it is not only the deep sea. On warm nights along certain bays and shores, the water itself can light up, glowing blue-green wherever it is disturbed, as a boat or a hand or a breaking wave stirs the tiny living things that drift there. Each one is far too small to see alone, yet together they can turn an entire shoreline to a field of cool blue fire that ripples with every motion. On land, fireflies rise on summer evenings, blinking their soft yellow lights to find one another in the dusk. In damp forests, certain mushrooms glow faintly in the night, a quiet, ghostly shimmer rising from the forest floor. When you take in how widespread this is, it begins to feel almost tender. Life, faced with the deepest and most total darkness there is, did not simply endure it. Life learned to make its own light. In the one place on Earth, most cut off from the sun, the creatures there grew their own small stars and carried them through the dark. So tonight, you might let your mind drift downward into that cool and silent deep, where the water is black and still, and the weight of the ocean is vast, and yet everywhere around you, soft lights are blinking and drifting and glowing. A slow constellation of living stars made by gentle creatures in the dark, rising and fading in the quiet, far below the reach of the sun. Let that soft underwater glow settle over you, calm and cool and unhurried, as you drift down towards sleep. Light is the fastest thing in the universe, and yet we have brought it to a complete stop. It sounds impossible, almost like a contradiction. Light is the very definition of speed. In empty space, it races along at around 300,000 kilometers every second, fast enough to cross from the Earth to the Moon in about a single second, fast enough that it could circle our entire planet 7 times while you draw one slow breath. Nothing outruns it. It is the swiftest thing there is. And yet, in a few quiet laboratories, careful hands have slowed that breathless speed down to a crawl, and then gently stopped it altogether. To see how this can be, it helps to know that light does not always travel at its full speed. That tremendous pace is the speed of light through empty space. But when light passes through something, through air, through water, through glass, it slows down a little, weaving its way among the atoms before emerging on the other side. This is happening all the time, in small ways. Light moves a touch slower through water than through air, and slower still through glass, and slower again through diamond. It is part of why a straw in a glass of water looks bent at the surface, and why a diamond catches the light so beautifully. Ordinary matter gently holds light back. But the truly astonishing slowing came when scientists cooled a small cloud of atoms to almost the coldest temperature there can be. A temperature just a hair above absolute zero, far colder than the depths of space. At that extreme, the atoms grow strangely still and begin to behave as one, settling into a delicate, dreamlike state of matter. And when a pulse of light was sent into this ultra-cold cloud, something remarkable happened. The light slowed and slowed and slowed until it was crawling along at the speed of a bicycle. Light, the fastest thing in all creation, moving slowly enough that a person could jog alongside it and keep pace. To feel how enormous that change is, hold the two speeds side by side. In open space, light could cross an entire country in the blink of an eye, quicker than thought, quicker than anything we have words for. Inside that cold cloud, its pace had fallen from the unimaginable all the way down to something a child on a bicycle could match. The same light, the same beam, gentled by a factor almost beyond counting, until the swiftest thing in existence was simply ambling along. And then they went further. By carefully tuning the cloud, the scientists were able to bring the pulse of light to a complete halt. The light simply stopped, held motionless inside the cold cloud of atoms, still as a held breath. And here it is worth being clear about what is happening, because it is even stranger and more beautiful than it first sounds. The light is not merely sitting there glowing in the dark. When the pulse stops, its pattern, the very information it carries, is gently handed over to the atoms themselves and stored within them, while the light's own glow fades away. The light becomes, for a moment, an imprint held in matter. And then, when the scientists choose, they can release it. The atoms hand the pattern back, the pulse of light reappears, and it continues on its way as though it had only paused to rest. A beam of light stopped, stored, and then sent onward again, all at the gentle command of human beings. It is worth saying plainly that none of this breaks the great rule of the cosmos. The speed of light through truly empty space has never changed and never will. What these experiments do is coax light into slowing and stopping inside special matter, under conditions of extraordinary cold and care. The fastest thing in the universe still races on, untouched, out in the emptiness between the stars. It is only here, in these delicate clouds of ultra-cold atoms, that we have learned to take it gently in hand and ask it for a moment to be still. There is something quietly moving in that thought. For all of history, light has been the very symbol of all that is swift and untouchable, the thing that cannot be caught or held. And yet patient human curiosity, armed with little more than cold and cleverness, found a way to cradle a pulse of light, to slow its endless rushing, and to hold it, briefly, perfectly still. We caught the uncatchable, not by force but by stillness, by making a place so cold and so calm that even light could rest there. So tonight, you might picture that. Somewhere, in a quiet room, there's a tiny cloud of atoms colder than the void between the stars, hushed and motionless. And resting within it, paused in the middle of its endless journey, is a small pulse of light, waiting in perfect stillness to be set free again. Let that image settle over you. The fastest thing in the universe, brought gently to rest, calm and quiet and held as you grow still yourself and drift towards sleep. There is a place in the universe where light goes in and never comes back out. Scattered through the cosmos are objects so dense, so deeply collapsed in on themselves, that they bend the space around them past the point of return. We call them black holes, and around each one lies an invisible boundary, a threshold drawn in empty space beyond which nothing can ever escape. Beyond it, escape becomes impossible for everything, from the largest spaceship to the faintest signal, and even for light itself, the fastest thing there is. Cross that line, and you are gone from the rest of the universe forever. This boundary has a name. It is called the event horizon, and it is one of the strangest and most absolute things we know to exist. To understand it, think for a moment about throwing a ball straight up into the air. It rises, slows, and falls back down, pulled by the Earth's gravity. Throw it harder, and it climbs higher before returning. And if you could somehow throw it hard enough, fast enough, it would escape the Earth's pull entirely and sail off into space. Every world has a certain speed you would need to reach in order to break free of it. And for the Earth, that speed is very high, but not impossible. Rockets reach it every time they leave for orbit. Now imagine an object whose gravity is so overwhelming that the speed you would need to escape it climbs higher and higher until it reaches the speed of light itself. At the event horizon of a black hole, this is exactly the case. To escape from that boundary, you would need to travel at the speed of light, and to escape from just inside it, you would need to go faster than light, which nothing in the universe can do. So light that crosses the horizon, racing outward as fast as anything can possibly go, still is not fast enough. It cannot climb back out. It falls inward along with everything else, and the door closes silently behind it. What makes this so eerie is that the event horizon is not a wall or a surface you would crash into. It is simply a place in empty space, unmarked and invisible. If you were to drift toward a large black hole, you might cross that fateful boundary without feeling a thing, without any flash or barrier to tell you the moment had come. One instant, you would be in the universe we share, able, in principle, to turn back. The next instant, you would be sealed inside, with no way to return and no way to send word, even though nothing around you seemed to have changed at all. The horizon is a one-way threshold, a point of no return that you could pass through without even knowing it was there. And because no light can escape from beyond it, a black hole is truly black. We cannot see the thing itself, only the darkness where it sits. But we can see what happens around it. Gas and dust spiraling inward, heated until they blaze, ringing the darkness in brilliant light. Stars near the center of our own galaxy whipping around at tremendous speed, circling something massive and unseen. And in recent years, astronomers have even managed to capture an image of the shadow of a black hole, a dark, round void ringed by a glowing halo of light bent around its edge. The first time human eyes have looked upon the silhouette of one of these objects. The light cannot escape from within, but the light passing nearby is bent and gathered into a bright ring, tracing the outline of the darkness like a halo around a shadow. As for what lies beyond the horizon, deep inside, the honest answer is that we do not truly know. Our finest theories, which describe the rest of the universe so beautifully, begin to break down and lose their footing in there, where matter is crushed beyond anything we can yet describe. The interior of a black hole is one of the genuine frontiers of human understanding, a place our knowledge has not been able to follow. We can map the boundary with great confidence, but what happens past it remains, for now, a mystery sealed away from us, perhaps forever. There is something strangely peaceful, even reverent, in that thought. In a universe we have explored so far and understood so much of, here is a place that keeps its secret perfectly. A door that opens only inward, a darkness that gives nothing back. The light that falls into it carries its story across the threshold and is gone, and the rest of the universe simply goes on around it, calm and bright, circling that small, silent absence. So tonight, you might let your mind rest gently on that distant image. Far out in the dark, a black sphere hangs against the stars, ringed by a thin, glowing halo of light that bends around it but can never quite fall in. Silent, patient, and utterly still, keeping its secret in the depths of space, while the soft light circles slowly at its edge. Let that quiet darkness settle over you, calm and vast, as you drift down towards sleep. Hidden inside the light of every star is a coded message telling us exactly what it is made of. It seems as though it should be impossible. The stars are unimaginably far away, so distant that we will almost certainly never travel to them, never gather a piece of one in our hands, never set foot upon their burning surfaces. And yet we know what they are made of. We know the ingredients of stars that lie thousands of light years away, stars we can only ever see as faint points in the dark. We know this not by visiting them, but by reading their light, because the light a star sends us carries, woven into it, the secret of its own composition. The key is something you can glimpse for yourself with a simple prism, or in a rainbow after the rain. When light passes through a prism, it spreads out into a band of color, from red through orange and yellow and green to blue and violet. This happens because the different wavelengths of light bend by slightly different amounts, fanning the colors apart. And when scientists first spread the light of our own sun out this way and looked at it very closely, they found something unexpected. The smooth band of color was not perfectly continuous. It was crossed by thin, dark lines, narrow gaps where certain exact colors were missing, as though something had quietly reached in and plucked a few precise threads from the fabric of the light. Those dark lines turned out to be a kind of fingerprint. Every kind of atom, every element, drinks in light at its own particular set of wavelengths, and only those. Hydrogen absorbs one exact pattern of colors. Helium absorbs another. Iron and sodium and calcium each have their own. So when the light of a star passes outward through the cooler gases of its own atmosphere, those gases sip away their own special colors, leaving thin, dark gaps in the rainbow exactly where they drank. The pattern of missing lines is a signature, and each element signs its name in a place no other can. Read the gaps, and you can name the ingredients of a star you will never touch. This is how we came to know the stars so intimately from so far away. We can tell that a distant sun is rich in hydrogen, laced with traces of heavier elements forged deep in its core. We can read its temperature from the colors it shines most strongly. And there is a lovely piece of history hidden here. The element helium, which fills floating balloons and makes voices squeak, was first discovered not on Earth at all, but in the light of the sun. Scientists found a mysterious line in sunlight that matched no element then known, and concluded there must be some new substance up there in our star. They named it after the old word for the sun, and only later did anyone find it here on Earth. We knew of something in the heart of the sun before we ever held a trace of it in our hands. The light carries even more than the recipe. The exact positions of those dark lines can shift ever so slightly, depending on whether a star is moving toward us or away. When a star drifts away from us, its light is stretched a little, and the lines slide toward the red end of the rainbow. When it moves closer, the light is gently squeezed and the lines slide toward the blue. By measuring these tiny shifts, we can tell not only what a star is made of, but how it is moving through space, whether it is racing away or drawing near, even whether it is being softly tugged back and forth by an unseen planet circling it. A single thread of starlight, caught after its long journey, tells us the star's makeup, its warmth, and its motion all at once. When you let this sink in, it is genuinely wondrous. A faint beam of light, having traveled across an ocean of darkness for centuries or far longer, arrives at last in a quiet observatory, and folded within it is the full story of the world that made it. We did not have to go there. The light came to us, and it brought the answer with it, written in lines of shadow that only patient eyes could learn to read. The whole of a distant sun, its substance and its warmth and its journey, carried gently across the void in a ribbon of color. There is a deep tenderness in that, if you let yourself feel it. The universe is not silent and unknowable. It is, in its own quiet way, always speaking, always sending out the story of itself in the light that pours from every star. We only had to learn how to listen, how to spread that light into its colors and read the gentle gaps within. So tonight, you might picture a single ray of starlight, ancient and far-traveled, fanned softly into a quiet rainbow. And there, threaded through its colors, the fine dark lines that whisper what it is, where it has been, and how it moves. A message written in light, crossing the dark for ages, only to arrive at last and tell its gentle secret. Let that soft glow settle over you as you drift down towards sleep. Two particles of light can be linked so deeply that touching one seems to stir the other, no matter how far apart they have drifted. This is one of the strangest discoveries in all of science, so strange that even the greatest minds resisted it for years. It begins with the idea that light comes in tiny pieces, called photons, the smallest possible grains of light, and under the right conditions, two photons can be born together in a single event, joined in a peculiar way that physicists call entanglement. Once they are entangled, the two photons are bound by an invisible thread, sharing a single linked fate even after they fly apart and travel off in opposite directions. Here is what makes it so uncanny. Each photon carries certain properties that, until they are measured, are genuinely unsettled, hovering in a haze of possibility, not yet decided one way or the other. And when two photons are entangled, their unsettled properties are tied together. The moment you measure one of them and its property finally settles into a definite answer, the other photon's matching property settles too, instantly, into the partnered result, however far away it has gone. You could carry one photon to the far side of a city, or in principle to the far side of the world, and at the very instant you measure the one in your hand, the distant one falls into step with it, as though the two had whispered to each other across the gap in no time at all. Albert Einstein found this so troubling that he called it spooky action at a distance. It seemed to him that there must be some hidden explanation, that perhaps the two photons had simply carried secret instructions all along, agreed upon at their birth, like two travelers each given a sealed envelope to open later. If that were so, there would be nothing mysterious about it at all. They would only be revealing answers they had carried from the start. But careful experiments, performed with great ingenuity over many years, have shown that this comforting explanation cannot be right. The photons are not carrying secret, pre-written answers. The outcome truly is unsettled until the moment of measurement, and yet the two still match every time across any distance. The link is real, and it runs deeper than any hidden note could ever explain. And now comes the part that must be said plainly, because it is so easily and so often misunderstood. This instant connection cannot be used to send a message faster than light. It cannot carry a phone call or a signal or any information at all across that gap in an instant. The reason is gentle and subtle. When you measure your photon, the answer you get looks completely random as the toss of a coin. You cannot choose what it will be, and so you cannot use it to send a chosen message. The distant photon does match yours, but whoever holds it sees only their own random-looking result, with no way to know that anything has happened. The hidden agreement between the two reveals itself only later, when you bring your results together and compare them, side by side, through ordinary means that travel no faster than light. The connection is real and instant, and yet nature has arranged things so cleverly that no message can ever ride upon it. The great rule that nothing outruns light stays perfectly safe. So we are left with something both real and impossible to fully picture. Two specks of light born together in a single flash, sent off into opposite distances, and forever after answering as one. Not through any signal we can detect passing between them, and not through any secret carried from the start, but through a connection woven into the deepest fabric of reality. One that binds them across any gulf, while still, somehow, keeping faith with the law that no message may outpace the light. There is something quietly beautiful in that, if you sit with it. The universe holds together connections we can barely imagine. Threads of relationship that stretch across vast emptiness without weakening, without fading, without any need for the two things to be near one another at all. Two photons, parted and sent across the dark, remain bound in a single shared fate, answering together in the same instant, as faithful at a distance as they were at the moment of their birth. You do not need to untangle the mystery of it tonight. You can simply let it rest in your mind as one of the gentle, strange truths of the world, that light can be joined to light across any distance, quietly and faithfully, in a way no one yet fully understands. Two small lights, born together, drifting apart into the dark and forever keeping their quiet promise to match. So picture them now, those two faint photons, gliding away from one another into the vast and silent night, growing ever more distant and yet still bound, still linked, still answering as one across all that space. Let that soft image carry you, calm and wondering, as you settle into stillness and drift gently down toward sleep. Light does not always travel in a perfectly straight line. We are taught early on that light goes straight. A beam crosses a room in a straight path. A ray of sunlight falls in a straight shaft through a window, and this is true enough for the small world around us. But across the vastness of space, something gentle and strange happens. When light passes close to something very massive, a heavy star, an enormous galaxy, it bends. Its path curves ever so slightly, drawn aside by the sheer weight of what it passes. Light, the thing we trust to travel true, can be quietly steered by gravity. To understand how, it helps to picture space itself not as empty nothingness, but as something that can be shaped. Imagine a smooth taut sheet stretched out flat, and then a heavy ball set down upon it. The sheet sags and curves around the weight, dipping toward it. Now roll a small marble across that sheet, and as it nears the dip, its path bends, curving around the heavy ball. This is something like what mass does to space. A massive object creates a kind of valley in the fabric of space around it, and anything passing through, including a beam of light, follows the curve of that valley. The light is not pulled the way a stone is pulled. It simply travels straight through a space that has itself been bent. This was one of the boldest predictions ever made about the universe. A young Albert Einstein, working out how gravity and space and light all fit together, came to a startling conclusion. Starlight passing near the sun should be bent by the sun's gravity, so that stars appearing close to the sun in the sky would seem to shift slightly out of place. For years, there was no way to check it because the sun's glare drowns out the stars beside it. But during a total eclipse, when the moon covers the sun and the sky goes briefly dark, those stars become visible. And so, during an eclipse long ago, astronomers carefully measured the positions of stars near the darkened sun and found them shifted exactly as predicted. The light had bent. Gravity had bent it. It was a quiet moment that changed how we understand everything. And the bending goes far beyond our own sun. Out in the depths of space, entire galaxies, vast islands of billions of stars, are so massive that they bend the light passing near them in dramatic ways. When a distant galaxy lies almost directly behind a closer, massive one, the light from the far galaxy is bent around the near one as it travels toward us, curving past on every side. And instead of seeing a single point of light, we see something remarkable. The distant galaxy's light can be smeared into a glowing ring, wrapped around the nearer mass like a halo, its image stretched and curved by the bending of space. Sometimes it appears as several copies of the same galaxy, scattered around the lens, the same far light arriving by several bent paths at once. This bending has become one of our most beautiful tools. A massive galaxy, by curving and gathering the light of things behind it, acts like a giant natural lens floating in space, magnifying the faint light of objects so distant we could never otherwise see them. By looking through these cosmic lenses, we can glimpse galaxies near the very edge of the visible universe, their light gathered and brightened by the gravity of whatever lies between. The universe, in a sense, hands us magnifying glasses made of nothing but curved space and the weight of galaxies. There is something quietly moving in this. We think of gravity as the force that holds our feet to the ground, that keeps the moon circling the earth and the earth circling the sun. But gravity reaches further than that. It shapes the very path of light, bending the oldest, fastest, most untouchable thing in the universe, steering it gently across the cosmos. Even a beam of light is not free of the shape of space. It must follow the curves and valleys that mass carves into the fabric of everything. So the next time you imagine light crossing the vast dark between the stars, you might picture it not as a perfectly straight arrow, but as a traveler following the gentle contours of space itself, dipping and curving as it passes the great masses along its way, bending around galaxies, gathering into soft rings of light, finding its way to us along paths quietly shaped by gravity. And tonight, you can let that image settle over you. Far out in the deep, the light of a distant galaxy is curving softly around an unseen mass, smeared into a faint and glowing ring, traveling toward us along a bent and gentle through the curved fabric of space. Let that slow, quiet bending carry you, calm and unhurried as you drift down toward sleep. The blue of the daytime sky is not really up in the sky at all. It is sunlight, scattered. On a clear day, you look up and the whole dome above you glows a soft, even blue from one horizon to the other. It seems as though the sky simply is blue, as though blueness had been painted onto the heavens. But the sky has no color of its own. What you are seeing is sunlight, white sunlight, broken apart and scattered across the air, and the reason it looks blue is a small and lovely quirk of how light and air meet. Sunlight, though it looks white or pale gold, is actually a blend of every color woven together. When all the colors of light mix, they make white, and so the light pouring from the sun carries red and orange and yellow and green and blue and violet, all traveling together. Now the air above you is not truly empty. It is filled with countless tiny molecules, far too small to see, drifting and jostling everywhere. And when sunlight streams into this sea of air, those molecules nudge the light, scattering it, sending it bouncing off in new directions. But they do not scatter all the colors equally. The shorter, tighter waves of light, the blues, are scattered far more strongly than the longer, lazier waves of red. The blue light gets knocked about, ricocheting again and again off molecule after molecule until it is spread all across the sky, raining down toward you from every direction at once. And so wherever you look, blue light is arriving at your eyes, and the whole sky glows with it. There's a subtle detail worth a gentle mention. Violet light is scattered even more strongly than blue, so you might wonder why the sky does not look violet instead. The answer is partly that the sun sends out less violet light to begin with, and partly that our eyes are simply more sensitive to blue, so the sky settles into that soft blue we know, a blend of the scattered light and the eyes that receive it. And then comes the evening, and the very same scattering paints a completely different picture. As the sun sinks toward the horizon, its light no longer comes down to you from overhead. Instead, it comes in low and slanting, skimming a long, long way through the air before it reaches you. Over that much greater distance, nearly all of the blue light is scattered away, knocked aside in every direction long before it arrives, until little of it is left. What remains, what survives that long journey through the air, are the warm colors, the oranges and the deep reds, the longer waves that are not so easily turned aside. And so, at the end of the day, the light that reaches you has been emptied of its blue and left glowing with fire, and the horizon burns with warm color as the sun goes down. It is the same effect, the very same scattering of light by air, producing the gentle blue of noon and the burning red of sunset. The only difference is the path the light must travel. Overhead at midday, a short path, and the sky is blue. Low at the horizon at dusk, a long path, and the sky turns to flame. The color of the sky is simply a story about how far the sunlight has traveled through the air to reach you. When you take this in, there is something quietly wonderful about it. The colors that fill your days, the calm blue of the afternoon, the glowing red of evening, are not fixed features of the world hanging above you. They are made fresh in every moment, out of plain white sunlight and the simple air, shaped only by the angle of the sun and the distance its light must cross. The sky is not painted. It is happening continuously in the meeting of light and atmosphere. And there's a tenderness in knowing that every sunset you have ever loved was the long light of the sun, threading its way through miles of air, losing its blue along the road, arriving at last as warmth and color just for the moment you happen to be watching. The same sun, the same air, giving a different sky depending only on where the light has been. So tonight, as the day's last colors fade, you can hold this gentle thought. The blue that filled the sky above you today was sunlight, scattered soft across the air. The red that closed the evening was that same light, worn warm by its long journey to your eyes. And now both have slipped away into the quiet dark, leaving the calm of night to settle over you as you let your eyes close and drift gently down towards sleep. High above the frozen poles on certain nights, the sky itself begins to glow and ripple with light. Great curtains of soft green and rose hang shimmering in the dark, swaying and folding as though stirred by a wind you cannot feel. They brighten and fade, stream across the stars, and pour like slow rivers of light over the snow. People have watched these lights for as long as there have been people in the far north and the far south, and have told countless stories about them. And the truth of where they come from is every bit as wondrous as any of the old tales. Those dancing lights are made by our own sun, reaching across the emptiness of space to touch the air above our world. It begins far away with the sun. Our star does not only send out light, it also streams out a constant gentle wind of tiny particles, fragments far smaller than dust, flung off the sun and racing outward across the solar system in every direction. This stream washes endlessly over the Earth, and on most of us it has no effect at all because our planet has a quiet, invisible shield. The Earth is wrapped in a vast magnetic field, an unseen web of force that surrounds the whole world, and this field deflects most of those incoming particles, steering them harmlessly around us. We live, always, inside that protective embrace, rarely aware that it is there. But the shield is shaped in such a way that it funnels some of those particles down toward the two poles, the far north and the far south, guiding them along its invisible lines toward the top and bottom of the world. And there, near the poles, the particles are drawn downward, plunging into the upper reaches of our atmosphere, miles and miles above the ground. High up there, they collide with the molecules of air, striking them, jostling them, pouring energy into them. And when those molecules of air receive that energy, they do something beautiful. They glow. This is the secret of the lights. The shimmering colors you see are the air itself, high in the sky, lit up from the energy of particles sent by the sun. And the different colors come from different gases in the air, each one glowing in its own hue. Oxygen, struck high in the atmosphere, gives off that signature soft green, and sometimes higher still, a deep and gentle red. Nitrogen lends its own touches of blue and violet to the edges of the curtains. The whole glowing display is a kind of vast, silent sign written across the sky, lit not by any earthly hand, but by the meeting of our star's wind and our planet's air. And these lights appear not at one pole alone, but at both ends of the Earth at the very same time. When the northern sky glows with its curtains of green, the far southern sky is very often glowing too, in a quiet mirror image at the bottom of the world. The same gentle fire kindled at both poles by the same distant sun. They unfold high above us, higher than any cloud, higher than the airplanes cross, far up at the thin and delicate edge of our atmosphere, where the air thins away toward the emptiness of space. The glow you see is happening at the very roof of the sky, and the reason the lights seem to dance, to ripple and shift and flow, is that the streams of particles and the magnetic field that guides them are themselves always moving and changing. The curtains sway because the invisible forces shaping them sway. What you are watching when you watch the lights move is the restless, shifting meeting of the sun and the earth, made visible for a little while in glowing color. When you understand what you are truly seeing, it can fill you with a soft wonder. The aurora is not separate from us, not some distant cosmic event happening far away. It is the very place where the sun reaches out and touches our world, where our star's wind meets our planet's shield and air, and that meeting blooms into light right above our heads. It is the sun and the earth in quiet contact, and we are given to see it, glowing gently in the polar night. There is something deeply peaceful in that thought. Above the silent, frozen lands at the ends of the earth, our star and our world are gently meeting, and the sky answers with slow rivers of green and rose, rippling without a sound. A vast and beautiful exchange, painted in light, unfolding quietly over the snow, whether anyone is there to see it or not. So tonight you might let your mind drift up to those high, cold skies, where the great soft curtains of light are swaying in silence over the white land below. Pale green and gentle rose, folding and flowing among the stars, lit by the patient touch of the sun upon the air. Let that slow, silent dance of light settle over you, calm and unhurried, as you drift down toward sleep. Deep in the water around the heart of a nuclear reactor, there glows an eerie and beautiful blue light. It is a soft, otherworldly blue, calm and steady, filling the clear water like something out of a dream. Those who work near these reactors know it well, this gentle blue glow rising from the depths of the cooling pools that surround the reactor's core. It is strangely lovely, almost serene, and the story of where it comes from leads us to one of the most surprising facts about light, a place where something can briefly outrun a beam of light, but only because of a quiet loophole hidden in the rules. To understand it, we have to remember something gentle about how fast light truly goes. We often say that nothing can move faster than light, and in the emptiness of space, that is absolutely true. Out there, light travels at its full, ultimate speed, and nothing with any substance can ever catch it. But light does not always move at that full speed. When light passes through something, through water, through glass, through air, it slows down. In water, in particular, light travels noticeably slower than it does in empty space, moving at only about 3/4 of its top speed, held back as it weaves among all the molecules of the water. And here's the loophole. While nothing can ever beat light's speed in the emptiness of space, a fast-moving particle can travel through water faster than light itself travels through that same water. The particle is still moving slower than light's ultimate speed in the vacuum, so the great cosmic rule is never broken. But it can outpace the slowed-down light within the water. Inside a nuclear reactor, tiny particles are flung outward at tremendous speeds, fast enough that, when they shoot through the surrounding water, they are racing along faster than light can travel through that water. And when that happens, the particles leave a glow behind them. You can picture it through a familiar image. Think of a boat moving across a calm lake. If the boat moves slowly, the ripples it makes simply spread out ahead of it. But if the boat moves faster than its own ripples can travel through the water, it piles those ripples up into a sharp wake, a spreading V trailing out behind it. Or think of a jet flying faster than sound, building up the sudden crack of a sonic boom as it outruns its own noise. Something very similar happens with these particles and light. As they race through the water faster than light moves there, they build up a kind of wake of light, a cone of glow trailing behind them, and that glow shines in a soft and beautiful blue. It is worth pausing to say this clearly because it is so easy to misunderstand. Nothing here is moving faster than light in the way that would break the laws of the universe. Nothing is outrunning light in empty space. The particles only manage to outpace the slowed light within the water because the water holds light back while letting the particles rush nearly unhindered through. The great rule that nothing exceeds the speed of light in the vacuum remains perfectly intact. This blue glow is simply what it looks like when something beats light at its slower, gentler pace inside the water, a glimpse of a rare and subtle corner of how light behaves. When you take this in, there is something quietly beautiful in it. Light, the fastest thing in the universe, can be slowed just enough by passing through water that for a moment something else can pull ahead of it. And the universe marks that strange overtaking with a soft and silent glow. It is as though the water itself lights up in gentle answer, painting the path of the unseen particle in a calm and lovely blue, a beauty born not from breaking the rules, but from one of their subtlest and most delicate folds. And this same gentle glow has quietly become a tool of discovery. Far underground, in enormous tanks of pure water shielded from the noise of the world above, scientists watch for tiny fleeting flashes of exactly this blue light. When a rare and ghostly particle from the depths of space, or from the heart of the sun, or from a distant exploding star, races through the water faster than light can travel there, it leaves behind a faint blue glimmer, a momentary spark in the dark. By watching patiently for these soft flashes, we can catch sight of particles that would otherwise pass straight through us and through the whole of the earth, entirely unseen. The same glow that fills the reactor pools becomes a way of listening to the quiet messengers of the cosmos. So tonight, you might picture that still, deep pool, the clear water calm and undisturbed, and rising from within it that soft, dreamlike blue light, glowing steadily in the quiet, a gentle, otherworldly radiance, calm as still water, shining in the depths from the silent passage of particles too small to see. Let that serene blue glow settle over you, soft and tranquil, as you drift gently down towards sleep. The light of a laser is ordinary light, gathered up and taught to march in perfect step. We are surrounded by light of all kinds, the glow of a lamp, the brightness of the sun, the soft flame of a candle, and all of it shares a certain wildness. It spills out in every direction, in a jumble of many colors mixed together, with its waves rising and falling out of step with one another, each going its own way. This is ordinary light, and it is beautifully chaotic, scattering outward to fill a room or light up a whole sky. A laser is something different. A laser is light brought into order, every wave aligned, every part moving together as one, and that single change from chaos into harmony is what gives a laser its remarkable powers. To feel the difference, imagine the light from a simple bulb. Its waves come in a whole spread of colors, blending into white, and they pour out every which way in all directions, rising and falling with no coordination at all. You might think of it like a crowded room full of people all talking at once. Every voice a different word, a different pitch, overlapping into a warm and shapeless murmur. That is ordinary light, a happy noise of many colors and many directions all at once. Now imagine instead that everyone in that room began to sing the very same note, at the very same moment, perfectly together. The sound would gather into something pure and powerful and clear. That is what a laser does with light. It coaxes the light into a single color, a single wavelength, with all the waves lined up crest to crest, all marching in the same direction, in perfect unison. How light is coaxed into such perfect order is itself a gentle marvel. Inside a laser, countless atoms are prompted to release their light not at random, but each one in step with the light already streaming past, adding its own small wave precisely in time with the others. One aligned wave prompts another, and that one prompts another still, in a quiet growing chain, until a great host of light waves are all rising and falling together as one. The light builds itself up into harmony, each atom falling into rhythm with its neighbors, until what emerges is a single pure beam, every wave moving in flawless unison. This is what makes a laser's beam so different from the glow of a lamp. Because all its light is lined up and moving the same way, it does not spill outward and spread thin. It travels in a tight, narrow beam, staying slender and focused over great distances. A clean thread of light reaching out straight and far. The orderliness is so complete that we've aimed laser beams at mirrors left long ago on the surface of the moon, sent the light all that way across space, and caught the faint reflection coming back, using it to measure the distance to the moon with astonishing precision. A beam of ordinary light would have spread and scattered into nothing over that vast journey. The laser, marching in step, held together well enough to make the trip there and back. And this gentle discipline of light has quietly woven itself all through our world. The same orderly light, focused to a fine point, can cut through metal or perform delicate surgery with a steady hand. It reads the patterns of barcodes at a shop and once read the music and movies stored on shining discs. Perhaps most quietly wondrous of all, pulses of laser light race through hair-thin threads of glass beneath the oceans and across the continents, carrying our voices and our messages, and the endless flow of the internet as flickers of light flashing through the dark at tremendous speed. So much of modern life rests, unseen, on light that has been taught to move in step. When you take this in, there is something quietly thought-provoking about it. The power of a laser comes simply from order, from coordination, from light all moving together rather than scattering every which way. It is not a matter of the light being brighter or hotter than any other. It is the very same light that spills harmlessly from a bulb, made able to cut and measure and carry the world's words only by being brought into harmony. It is a gentle reminder that order itself can be a kind of power, that things aligned and moving together can do what those same things scattered never could. There is a soft beauty in picturing it, a single pure thread of light, one color, every wave and step, reaching out perfectly straight into the distance without spreading or fading, calm and clean and unwavering. Light gathered from its natural wildness into quiet, ordered grace. So tonight, you might let that image rest gently in your mind. a slender beam of pure light, all its waves moving as one, traveling smooth and straight and unhurried into the dark. The wild, scattered light of the world, gathered softly into harmony, reaching quietly outward as you let yourself grow still and drift down towards sleep. The shimmering pool of water on the hot road far ahead is not water at all. It is a piece of the sky bent down to meet you. You have surely seen it. On a hot day, looking down a long stretch of road, the distant surface seems to glisten as though covered in water, with a wet shine that wavers and trembles in the heat. And yet as you travel toward it, the water is never there. The shining patch keeps its distance, always a little further on, retreating as you approach, until you give up trying to reach it. This is a mirage, one of the gentlest tricks that light plays, and it is not a confusion of your mind. It is a real bending of light through the air, as honest as a reflection in a still pond. To understand it, we have to remember that light bends when it passes between air of different temperatures. Hot air is thinner and lighter than cool air, and when light crosses from one into the other, its path curves, just slightly. On a hot day, the air right above the sun-baked road becomes very hot, while the air a little higher up stays cooler. So there's a layer of hot, thin air hugging the ground, with cooler air resting above it. And as light from the sky travels down toward that hot layer, it bends, curving upward again before it ever reaches the road, swooping back up toward your eyes. So when you look at the distant road, some of the light entering your eyes is not coming from the road at all. It is light from the bright sky above, bent upward off the hot air, arriving as though it had risen from the ground. Your eyes simply follow that light back along a straight line and place a patch of sky down upon the road, shimmering like water. The mirage is the sky itself, gently folded down to the earth by the heat. This same bending of light through the air can do far stranger and grander things. Out over cold seas, the bending can run the other way, lifting the images of distant ships and shores up above the horizon, so that boats appear to float in the air, or far-off coastlines seem to hover and stretch into shimmering shapes like castles. Sailors have long told of such sights, of cities and cliffs rising impossibly from the sea, and many of them are real images of real things, bent and lifted and stretched by layers of air of different temperatures. The atmosphere, it turns out, is full of these quiet lenses, bending light in ways that can lift the world and rearrange it before our eyes. And there is one last gift the bending air can give, rare and brief and lovely. At the very moment the sun sets, as its last sliver slips below the horizon, the air can act like a faint prism, bending and separating the sun's colors by the tiniest amount. The different colors of sunlight are bent by slightly different degrees as they pass through the thick air at the horizon, and the blue is scattered away across the long journey, leaving the green to linger just a touch above the red. And so, for a single fleeting instant, the last visible point of the setting sun can flash a vivid, startling green, there and gone in a heartbeat. The green flash, it is called, and people travel far and watch many sunsets in the hope of catching that brief emerald spark at the edge of the sea. When you take this in, there is something quietly delightful about it. These are not illusions in the way a dream is. They are the genuine paths of real light, bent and curved as it travels through air of shifting warmth, arriving at your eyes having taken a gently crooked road. The water on the highway, the floating ships, the flash of green at the close of day, all of them are the air quietly playing with light, showing us the world refracted and rearranged. There's a soft wonder in realizing that the very air we move through, invisible and ordinary, is forever bending the light that crosses it in ways we mostly never notice. The world we see is subtly shaped by the warmth and the layers of the atmosphere, the light arriving always just a little bent from true. So tonight, you might picture that quiet horizon at dusk, the sun sinking slowly into the distant edge of the world, its last colors bending softly through the air. A final shimmer, perhaps a brief flash of green, and then the gentle settling of the light into evening. Let that soft bending light carry you, calm and unhurried, as you drift down towards sleep. Far, far into the future, the last star will burn low and flicker out, and the universe will grow quiet and dark. It is a gentle thought, not a frightening one, and it lies so unimaginably far ahead that no mind can truly hold the distance. But our best understanding of the universe tells a slow and graceful story about how the age of starlight may one day come to its close. The stars we see tonight, and all the stars that will ever be born, are part of a bright and fleeting chapter in a much longer tale. And that chapter, vast as it is, will not last forever. Stars are born from great clouds of gas drifting through space, gathering and collapsing until they catch fire and begin to shine. But the supply of that gas is not endless. With each new generation of stars, a little more of the universe's gas is used up, locked away inside stars, or scattered too thin to gather again. And so, across spans of time almost beyond meaning, fewer and fewer new stars will form. The great clouds will run low. The cosmos will go on making stars more and more slowly, until at last the gas to make them is nearly gone, and new stars cease to be born at all. And the stars that already shine will, one by one, reach the ends of their own long lives. Some will swell and gently let go of their outer layers, settling down into small dense embers that slowly cool. Some will end in brilliant bursts of light, but all of them, in their own time, will spend the last of their fuel and grow dim. The great blazing suns will fade to faint glowing cinders, and those cinders, over ages longer still, will cool toward darkness, until even their last warmth has drained away into the cold of space. Slowly, gently, across timescales that dwarf the entire history of the universe so far, the lights will go out. Here it is worth being honest and careful, because we are speaking of a future so distant that much about it remains uncertain. This is the picture our current understanding paints, our best reading of the physics we know, projected forward across spans of trillions upon trillions of years and far beyond. It is not a certainty, and there is a great deal we still do not know about how the universe will truly unfold across such unimaginable stretches of time. What we can say is that, as far as we can tell, the era of bright and shining stars appears to be a passing season, and a long, deep quiet seems to lie ahead. There is more, gentler still. The universe is expanding, the space between the galaxies slowly stretching ever wider, and that expansion appears to be speeding up. Over enough time, the distant galaxies will drift so far away and their light will be stretched so thin that they will fade from view entirely, slipping beyond our reach. The sky of the far future would be emptier than ours, lonelier, the distant lights gone, and then, in time, the nearer ones guttering out as well, like the last embers of a fire settling softly into ash. And yet there is something in this that is not sad at all. but quietly precious. If the bright age of stars is only a passing chapter, then we are living within it, right now, in the rare and luminous season when the universe is full of light. The night sky above you, scattered with countless shining suns, is not the universe's permanent state. It is a gift of timing, a brief and brilliant age, and we happen to be here to see it. We live in the time of light, when the cosmos blazes with stars, and that, far from being something to mourn, is something close to a wonder. We arrived in the bright part of the story. When you let this settle, it brings a soft and gentle peace. The eventual quiet of the universe lies so impossibly far ahead that it casts no shadow on this night, or on any night you will ever know. The stars are shining now. The light is pouring across the cosmos now. And you are here, beneath it all, in the warm and glowing middle of the age of light, with countless suns still burning softly overhead. So tonight, you can let the far future rest where it belongs, gentle and distant and unhurried, and simply be here in the time of stars. Picture the night sky above you, full and bright and alive with light, the great age of shining still unfolding all around you. Let that soft glow of a universe still full of stars settle over you, calm and warm and peaceful as you drift gently down towards sleep. And so we come softly to the end of our journey through the mysteries of light. If you are still awake, drifting somewhere on the quiet edge of sleep, there is no need to stir. You can simply let these gentle wonders linger, the ancient starlight and the colors made within you, the glowing creatures of the deep, and the soft bending of light through space. Let them settle into the warm dark behind your eyes. And if you would like a little more to carry you the rest of the way down, another quiet journey is always waiting for you here. Another slow wander through the wonders of the universe, ready whenever you are. Just let it begin and let yourself drift. But for now, there is nothing left to do and nowhere left to be. The light has traveled across the whole of the cosmos to find you here. And now it is time to rest. Let your breathing slow. Let the last of the day fall gently away, and let yourself sink softly into sleep. Sweet dreams among the stars.